A policy defines a requirement or a collection of requirements that the user must satisfy in order to access a resource. In fact, even if you use claim-based or role-based authorization, you are actually using policy-based authorization, but as hard-coded policies. Think of the roles decorator we created, which required a user to have a specific role, essentially creating a hard-coded policy implemented within our roles guard. Just as a disclaimer that in this lesson, we're going to be diving into some much more advanced scenarios of authorization that aren't typically required for most applications. Usually, roles-based or claims-based is sufficient for most use cases, but we thought it might be helpful to showcase policy-based authorization just in case you might need it for yourself in your future applications. Alright, so let's switch to our IDE and see how we could leverage policies in our application if we felt we needed them. Inside the authorization folder, let's create the following directories tree, policies/interfaces. In the interfaces folder, let's create a new file and name it policy.interface.ts. Inside of this file, let's declare a policy interface. This will be a very simple interface which will consist of one property, name, that we'll use to make debugging simpler. Next, let's create another file alongside the policy interface and name it policy-handler.interface.ts. Inside of this file, let's declare a policy handler interface. This interface requires that the handle method must be implemented. This handle method will take two arguments, policy, which is the corresponding policy instance for which this handler was implemented for. Note the generic type T, as different policy handlers will have their own dedicated policies. And our second argument, the active user data object, indicating what's the context user for which we're executing this policy on. Perfect. With these interfaces in place, let's now move on to the policy handler storage class. This class will serve us as a static map collection that associates policies with their corresponding policy handlers. Each policy should have exactly one policy handler. The policy handler will be in charge of processing a specific policy. Don't worry, all this will make much more sense in a moment. Let's start by creating a policy-handlers.storage file in our policies folder, and inside of this file, let's declare a simple class that contains one private collection under the hood. Also, let's make sure to annotate it with the injectable decorator. The first type argument we specify for the map class indicates the type of our keys in this collection. Since keys equals classes representing our policies, hence we need to use type of policy here. The second type argument we see here represents values for these keys. Here we've used policy handler of type any, as we'll be using policy handler instances as values. Note that in the case of keys, we operate on types, not concrete instances, as we want to enable developers to manually instantiate and configure policies, for example, if different endpoints in our application have different requirements. Alright, so enough theory. Next, we'll need two methods that let us operate on the internal collection of this storage class. Get, or retrieving the policy handler class based on the given policy class, and the method add, for associating policies with policy handlers. Note we've used the CLS suffix here to indicate we're operating on classes here, not instances. With this storage class in place, we can start creating our first policy. For demonstration purposes, we'll implement a very custom policy, framework contributor policy, that checks if the user's email address is registered under the nestjs.com domain. So inside our policies folder, let's create a new file and name it framework-contributor.policy.ts. Inside of this file, let's create a simple class called framework contributor policy and make it implement the policy interface. Let's also not forget to provide the name of this policy. Note, typically we'd recommend creating another file next to this one and calling it framework contributor policy-handler.ts. But since the framework contributor policy is very straightforward, short, and simple, in order to make things easier to comprehend and understand, we decided to create the handler class straight inside of this file right after the policy definition. So let's go ahead and create the framework contributor policy handler now. Once again, let's make sure it's annotated with the injectable decorator, and that it implements our policy handler interface. Next up, let's declare a constructor and inject the policy handler storage provider. Inside this constructor, using the policy handler storage add method we created a moment ago, let's associate this handler with the corresponding framework contributor policy as follows. Since all of our policy handlers are designed to be asynchronous, let's flag this method as async. And from here, we can start implementing our actual policy. Inside of the handle method, let's add the following logic you can find below the course video. In the code shown here, we are simply checking whether the user's email address ends with @nestjs.com, and if not, we throw an exception. And that's it. Remember, we are just creating a very simple policy for demonstration purposes, but hopefully you can see the possibilities here and why this type of authorization could be useful in certain applications and circumstances. Before we continue further, let's open up our IAM module file and make sure to register both policy handler storage and framework contributor policy handler classes as providers. This is why we added those injectable decorators after all. Great. Now there are two more steps we need to do that we already covered in previous lessons. First, inside of our decorators folder, let's create a new policies decorator for attaching policies to endpoints or controllers. Like always, all of the code for this can be found below the course video. Once we're done, let's create a new policies guard that runs context-specific policies for a given operation. We'll start by pasting our usual boilerplate, reading the metadata, ignoring the guard if policies aren't present, etc. We've done this a few times already in this course. And with this code in place, let's start implementing the policy-specific logic now. Now let's inject the policy handler storage we created, as we'll need it for retrieving policy handlers themselves. If policies are defined, then let's iterate through them, map to their corresponding policy handler instances, and call the handler method, passing the policy instance as a first parameter and the active user data as the second one. Note, to retrieve the corresponding handler, we have to pass the policy constructor reference. As you may remember, our policy handler storage associates handlers with policy classes and not instances. Since our policy handlers handle method are async, let's use the promise.all here to await the result. And in case any error was thrown, let's use catch and map the errors to the forbidden exception error. Perfect. With all of that in place, let's navigate to the IAM module file and swap the permissions guard with our new policies guard. Next, let's open up our coffee's controller file, and instead of using the permissions decorator, let's comment it out, and let's use the policies annotation, applying the framework contributor policy. Awesome. Note, you could apply multiple policies to a single endpoint as follows if needed. Alright, so let's save our changes, head over to Insomnia, and test everything to see these policies in action. Let's hit send and check to see if we can access the post/coffees endpoint. Note that if you're getting a 401 error, make sure to sign in again and update your access token. And yes, we can see we do have access, since our user's email address is user1@nestjs.com. Now, let's switch back to our IDE, open up our framework contributor policy handler class to, instead of checking for the presence of @nestjs.com, update it to expect @trilon.io. Let's save our changes, head over to Insomnia, and try to hit that same endpoint once again. And as we can see, we are now unauthorized to access this endpoint due to the policy authorization restrictions we have set on it. We covered quite a bit in this lesson, and hopefully you could see the value in policy-based authorization, but also how it really may not be necessary for every application, and especially not every endpoint. Like most tools, there's a use case for everything, and with what we've covered in this lesson, you'll be able to cover even the most complex authorization scenarios in your future Nest applications.